G'day. In this series of videos, we are doing some psychometric modeling. We're using Gaussian cumulative distribution function as our model, and what we're doing is we're drawing from a uniform distribution, and we're basically saying how well can we approximate that Gaussian cumulative distribution function by using a method of constant stimuli with samples from from uniform distribution. Now, if you haven't seen the previous videos, we've started from scratch. We've built this model up from nothing. And so if you want to see how we got to where we are now, stop this video here, go back to the start, you can see what we've done step by step. Now, in the last video, we had a shocker. We did a lot of loops, nested loops and stuff. And so that took us a fair bit of time to get our way through. But what we ended up with was this list of, this array of subarrays where we basically had access to the data, the raw data from every single trial that we performed at every single intensity. So here, remember, we have in this first array here, we had the responses of our subject from an intensity of 0. And then in this second array, we had all the responses of our subject from an intensity of 10, all the way up to all of the responses of that subject to an intensity of 100. And remember, we said that if the subject got that response correct, for that particular trial, if it was correct, we encoded that as a 1, whereas if they got it incorrect, we encoded it as a 0. But what we want to do is we want to try and recreate the Gaussian curve, the cumulative distribution function that we created at the start. Okay, the model, we want to see whether or not we can reconstruct the model using this uniform distribution and the method of constant stimuli. So what we need to do is we need to convert all of these, this raw data at each stimulus intensity into a probability or a proportion correct value. And so that's what we want to do in this video. It's quite an easy and quite a straightforward video. All I've done since our last video is I've just deleted all of the print statements from our experimental function. Sorry, our experiment function, because we don't need to print this stuff out anymore. Oh, I'm really quite close. Let me go back here. Okay. So, what have we got? Well, we've got access to the experimental response array, so that's all the raw data that we've got down here. So let's start another function. Let's get another function going, because we're trying to get it all modular, and we'll call it def analysis. Okay, and we want to pass into that the experimental response array. Okay, and in this function, we just basically want to convert our raw response data, okay, at each stimulus intensity, into a proportion correct. Okay, so here we go. So here is our experimental response array. So let's have a look. What we need to do, what's a proportion correct? Well, that's the number of trials correct divided by the total number of trials at that intensity, isn't it? So proportion is number correct divided by a number of trials. So we need to somehow get access to the number of correct. So we need to somehow get into each of these subarrays. Okay, we need to basically isolate just this array, okay, and look at the number of correct in just that array. So what we can do is we can say, okay, for I in range 0 to length experimental response array. Okay, again, this is not the most Pythonic way of doing it, but it will serve purposes. So this is going to initialize to 0, okay, and so therefore 0 is within the range 0 to the length of experimental array, because remember, this has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, did I miss one? 10. Oh, well, actually, it's got 11 arrays in there. I started counting at 0. Okay, so it's actually got 11 items in that array, and so we're just going to iterate through each of those items in that array. Sorry about that confusion before. So what we're going to do is going to access the first array, and we're going to basically say the sum of values. Okay, so we're going to take this first array here, and we're going to add up all of the values that are inside that array. So sum at this particular intensity equals, and the way that we can sum it up is just say numpy.sum, and then this will sum all of the values in the experimental response array at the current position. Remember, this is going to start off at 0, so it's going to basically return to us the 0th position in this experimental response array from here to here. Okay, and so the 0th position is going to be this first array here. Okay, so we're just going to sum up the values at that first array. Okay, why are we just summing them up? Well, remember how we encoded the correct and incorrect responses? Well, if we have a look here, because our correct response gives us 1, if we just add them up, it's going to give us the number of correct, the sum of the number correct. Okay, so that's why we've chosen 1 and 0. So we've got the sum at correct, so now we've got the number of correct is the same as the sum correct, because each correct adds 1 to the value. But now we need access to the number of trials, and so the way that we can do that is we just say number of trials, so number of trials at intensity. Well, that's just going to be the length of the array. So the length of this array is just the number of trials that we've done. Okay, and so therefore we would say experiment response array at the ith position. Okay, now you might say, well, Andrew, we've got access to the number of trials down here when we said, hey, we've got 10 trials per stimulus intensity. And I agree, yeah, we've definitely got that. So we could essentially put here, you know, a number of trials here, and we could just say a number of trials at intensity equals, you know, a number of trials. That's perfectly fine. But I'm going to leave it as just making sure that we use the length of the array itself as the number of trials. Okay, so we've got the number of correct is the sum at that intensity. Okay, and we're using this for loop here to basically go through each of the arrays in the experimental response array. We've now got the length, which is the number of trials, and so all we need to do now is we just say proportion correct at this intensity equals, well, it's going to be the sum at the intensity, okay, divided by the number of trials, number of trial at that intensity. So we just print proportion correct at the intensity here. So if we run this now, I think we actually have to call the function. So we'll call experimental analysis, I think it was. Is that what we called it? Oh, we just called it analysis. Okay, analysis. So we call this function, but we have to pass to it, remember, this experimental response array. So if we call this function now, it should now print out the proportion correct at each of the stimulus intensities. So if we have a look here, so here, this is the response array corresponding to a stimulus intensity of 0, and we look it up and got none of them correct, so therefore the proportion correct is 0, and that's what we see here in this first value here. We then go into the second array here, again 0, so 0 proportion correct. So let's go forward. So here, the first one here, they got 1, 2, 3, 4 correct, so 4 out of, we know that there's 10 trials there, 4 out of 10 is 0.4 or 40%, and so this is what we've got here, 0.4. And then the next one, 1, 2, 3, 4, 5, so they've got 5 out of 10 correct, 0.5, and then the next one they got 9 out of 10 correct, so this is 0.9. So you see how now we're able to cycle through each of these response arrays, add them up, divide it by the total number of trials in that array, and then that's giving us the proportion correct. Okay, but this is not really helpful printing it out on a trial by trial basis, on a loop by loop basis. Okay, so what we're going to do, okay, is we're actually going to build an array, and so we're going to say, okay, proportion correct equals an empty array, and then we're just going to essentially, okay, proportion correct dot append. Because it's an array, we can append a value into the end of that array, and we'll just append into it these proportion corrects that we've calculated, which is the sum divided by the number of trials at that intensity. And then what we'll do here is we'll then just return the proportion correct. Proportion correct. Since we're returning something, we need to then say PR correct. And then if we print this out now, print PR correct, we should see now a nice array where the first value in that array corresponds to the proportion correct at a stimulus intensity of 0. Proportion correct is not defined. What have I done wrong? Where are we? Oh, I've tried to give it something that doesn't exist. Okay. I've tried to append into an array that doesn't exist. So the first value in this final array, so here, these are the raw trials again. They got none of them correct, and so therefore the position in the proportion correct here, sorry, the first position in the proportion correct has 0. And then 0, and then 0. And then, oh, here they got 1 out of 10 correct, and so therefore you see this fourth position across here, it's 0.1. So you see now these values here are the proportion corrects that correspond to each of these individual experimental response arrays. So we're slowly going one step further to calculate the proportion corrects. So that's this video done. That's all I wanted to do here. It wasn't such a hard video as before. We don't need to do any of this printing out of the experimental arrays as follows. It's what we're going to do in the next video is we're going to do some plotting, and we're pretty much done at this stage. We're very close. So I'll finish this video here. See you in the next video. I hope you enjoyed it, and yeah, all the best.